Okay, we are doing linear programming section 1-8. I'd like you to read 53 through 56 fairly carefully before you watch this video. So pause it now and do that because it may not make as much sense if you've not read this. But linear programming, as you will have found out, is when you have a system of linear inequalities, and they're called constraints. And we'll do a problem in just a minute that will illustrate this. But you have boundaries. You know, you've got a maximum y value, and you've got a maximum x value, and you've got to stay inside that, so that this is a region within which lies your solution. But then there might be other constraints, a total number of things. When you sum them up, they have to be less than this, and maybe it has to be more than something like this. And then there might be other ratios that are involved that have to be like less than this amount, and you pretty soon get a region that is mapped out by these inequalities, and somewhere inside here, or on the edge of this more precisely, is your solution. And what we're going to do is we're going to find the vertices of all of these points, and then we're going to decide which corner gives us the maximum value for some function that's called the objective function. So we have constraints that bound this region, and then we have an objective function that will tell us which corner of this region is the best. Alright, so the problem I'm going to do is hiding underneath this, and it is a math team fundraising problem. Alright, we're going to pretend that the math team has got some sort of a fundraiser. They're going to do some sort of community service thing that is going to pay them to do this, and the veterans have done this before. They're upperclassmen or women, and they're going to invite along the newbies, the sophomore and freshman boys and girls that haven't done this before. And we're going to say that the constraints are that you have to have no fewer than 5 veterans, and you can't have more than 15 veterans. All right? And that you can have no more than 8 newbies. It's just too difficult to train those fresh people in. But you can have no fewer than 10 and no more than 20 total participants. All right, so fewer than 10 is not worth it, and they can't handle a group more than 20. But then there must be at least 1 veteran supervising every newbie. Okay, you can't send along 8 of those greenies and then not have them be supervised properly. So we're going to write inequalities for each of these, and then we're going to graph them. Okay, so you can pause the camera and try your own hand at this. Okay, the last part of the problem is the important part, and that is that the math team that's raising money for their good cause, it receives $25 for every veteran that works on their volunteer project, and every newbie, every new recruit gets 20 bucks. So we can write what is called the objective function, because our objective is that we want to raise as much money as possible. So the funds raised based on our veterans and our newbie workers is simply that it's 25 times the veterans plus 20 times the newbies. So that's quite a simple function, and we will attempt to maximize that. All right, you're back. I hope you did well. If it says no fewer than 5 and no more than 15 veterans, well, we're going to assign our variables to be x is equal, that is going to represent the veterans, we'll say, and y will then be the newbies. And so if I can have no fewer than 5 and no more than 15, I'm going to have 5 and then is less than, or x is going to be greater than or equal to 5, but less than or equal to 15. All right, and really for graphing purposes, we will do this separately. We'll just graph x has to be greater than or equal to 5, and x has to be less than or equal to 15. All right, but we can write it like that if we prefer. No more than 8 newbies, so our y values must be less than or equal to 8. Okay, no fewer than 10, no more than 20 total participants. Well, if I add my veterans plus my newbies, that has to be less than or equal to 20. but it has to be, if I add them up, more than or equal to 10. So I've got these two inequalities then. I could have represented them with 1 like this, but there's not space in the paper. Then there must be at least one veteran for every newbie. I'm just going to say that there must be, for every y, it's going to be less than or equal to the number of veterans. I'll write it like that. Okay? So now I'm going to go to the graphing calculator and type those in. There's one problem with graphing vertical lines on our calculator, and I'll show you a little trick about that first. Okay, you know that our calculator always has its menu in the form of y equals, and we can do y equals 8 in our case quite easily, and we'll graph a line that's here. If that's 5, there's 10, and it's going to graph a solid line across. But we can't graph a vertical line. We have no way of typing in, at least in the 83 pluses. I think the 84s or one of the calculators has a clever way of doing it, but not most of them, doing vertical lines because there's no x equals. So this is a bit of a cheat, and I figured this out, and not many people do it this way, but if we want to graph a vertical line that goes through, in our case, 15, and then right here, 5, what we're going to do is we're just going to do an incredibly steep line that will intersect this, but it's going to intersect it way up at 1,000,000 points up at 0,1 million. So this is the little cheat here. We're going to type in y equals, and then the slope of this is going to be negative, because if it actually touches up here and comes down like that, it'll be negative. Y equals negative 1,000,000 6 zeros over the intersection point 15, and then that will be times x, and then the intercept is plus 1,000,000 456. All right, so that's the equation we'll type in, and then we'll replace this 15 with 5 when we want it to go in. So if you want to just remember this, anytime you want to graph a vertical line, you just can use 1,000,000. It's a nice number. It's big enough that it works. It's small enough that you don't have to type in 1,000,000 zeros. And then this is the x-intercept. Okay? And then that's a negative out in front. And you don't need parentheses, but then there's the x variable. I put parentheses around it just for clarity. And then plus 1,000,000. Again, just make sure you get the right number of zeros, and that will work. Okay?